We'll see if this has gone live. It looks like it's gone live. Just double checking everything. Would like somebody to give me some feedback as to whether the audio is okay and you can hear me. That would be nice. And welcome, yes, to the 100k live party. Thank you very much. I see there's been quite a few people waiting this afternoon. So hello to everybody in the chat. If you see me looking at different windows, it's because I've got various chats from different platforms. Excellent. Oh, hi. We've got some people recognise some familiar names already. That's good. So this is to celebrate, well, 2019, and it's been a good year for the channel. It's been a great year for the community. We just saw a community showcase, loads of cool things. And I think what we're going to do today is a code it yourself, which has become a bit of a tradition on this channel. Whenever we've got a milestone to celebrate, I subject myself to this ritual humiliation of writing bugs live. So what we're going to do is code a SHMUP, or a shoot 'em up, and it's going to be in the vein of those like crazy Japanese ones with bullets all over the place. And we'll see how far we get, because I'm not going to stream for hours and hours and hours. So we'll see how far we get today. Hopefully we'll get a nice framework in place. And that's really what I'm aiming for, because I've got a little prototype I've put together, so I'm not coding it completely from scratch. We shouldn't be getting too lost like we did in the 50k. I remember getting lost there, that was embarrassing. But what I'm hoping to provide is this framework, which is really extensible for creating your own shoot 'em up. So I'll just have a quick glance at some of the chats just to see what's going on. Wow, quite a few people have turned up already. That's really good. Thank you to those with lots of nice messages. I'm not going to read them all out now. I will say some things before we start. There is a prize draw. The link should be below the video that you're currently watching. There are 4 25 Great British Pound Steam vouchers up for grabs. It's a lucky dip draw, and you've got to answer a silly question, which should also be on the screen, I think, for you to see. Read only my messages. There you go, Red Cat. Right, so I think we'll just get started. So the idea is it's going to be a shoot 'em up, like a side-scrolling shoot 'em up with lots and lots of bullets. But I was quite keen to have a think about how we structure an engine for that. There'll be a few other announcements as well. I'm going to keep getting distracted until we get settled. Thanks for the congrats. What are we doing? We're programming a shoot 'em up game in the style of 1942, which is that really horrible one for the NES, but we'll be adding a bit more flair to it. Certainly a lot more particles, because we like particles in these live specials. I know some of you like to code along. That's fine. I will be probably going at quite a pace, but I think the gist will be quite acceptable for most of you. I'm going to be leaning quite a bit on what is so-called modern C++ in order to get things done. And this has come out of a drive of witnessing some conversations on the Discord forum about people not necessarily exploiting some of the things that modern C++ has to offer. And hopefully I can demonstrate through the course of this video that if you really do lean on the tools, you can get things working very quickly. As much as possible, I'm trying to keep up with the chat, but it is going a little bit fast. So if I do miss your messages, they're all recorded, and that's one of the reasons I like to put the chat on the screen so I can go back and look at them all later. I do like to try and read them all, because sometimes you suggest some really wonderful things. There's a few moderators in the chat already. In fact, I'll just make this guy a moderator. Now I can see that he's here. There you go. And I think we'll get started. So I'm going to be using the Pixel game engine. Now, you should all be very familiar with this from the channel. The Pixel game engine, rather excitingly, got loads of announcements, haven't I? It's going to get a bit of an update next year. I've got some plans for it. It will be considered Pixel Game Engine 2, but it will be 100% backward compatible with Pixel Game Engine 1. There's a few reasons, but I'll save that for the new year. But anyway, yes, today we're using Pixel Game Engine 1. Oh, and one final announcement to make, because I'll make this at the start and I'll make it at the end as well. Let me just bring in this window here so you can see. The community has decided that a OneLoanCoder community blog platform is a good idea, and I tend to agree with them. So I'm now hosting this at community.oneloancoder.com. And the idea is that the community can write articles and get them up there, and dev logs or reviews of games, technology, anything that interests us as a community really. It's early days yet, there's not very many articles on it, but if you want to write something and get it seen, because it gets a little bit of traffic, hopefully now, they've got a bit of a platform to push what the community is developing. It'd be, be nice to get this sort of underway and get people involved. So if you want to write some articles, register, reach out on the Discord, one way or another, contact me, and we can see about getting them posted. And it's got things like source code highlighting and images and things. So just wanted to get that in there before we start. I'll close that down now. Right, are we ready? I think I'm ready. I'm going to have a mouthful of water because we've got quite a few people here. And I don't often stream on YouTube. I tend to stream on Twitch. Twitch is a little bit more accessible for streaming. Right, so we've got a basic Pixel Game Engine application up here. I'm using 640 by 480 resolution, and my pixel to screen ratio is going to be 2. And all it does is create an empty window. Now, if we're going to create a shoot 'em up, I think the first thing we're going to need is a ship. So I will be glancing occasionally at my prototype because I just want to make sure I get the variable names that I've come up with consistent in the first place. So for the ship, all I really care about is where the player's position is. So I'm going to use an OLC vector floating point 2D type, and I use these quite a lot now. And I'm going to call that vPlayerPos. Very simple start. And I'm going to need a sprite to draw what the player ship looks like. I'm just going to move my microphone slightly, so do let me know if it's a problem. And I'm going to use an OLC sprite type here. I'll create a pointer to SBR player. Now, because I'm doing this live and I want to quite a bit to get through tonight, I will be cutting some corners regarding initializing variables and deleting things, but give me a break. So I want to load that sprite, and I've created 4 graphics. I actually got them from an asset pack on Humble Bundle, and I'm just going to use these basic graphics for tonight. So I want to load this sprite. Now I've got them in a subdirectory, GFX, and I've called it 100k player1.png. So we've got a sprite. And I think we'll add some rudimentary control in onUserUpdate to move that sprite around on the screen. So we're going to start very simply here, and then we'll build on it as we go through the video. Hopefully this will be available as a VOD straight away if you're late or you just want things to slow down a little bit. So I'm going to control the ship with the W, A, S and D keys. So if get key OLC W. Now, I don't want to respond to the events, I want to respond to the keys actually being held down. That gives it a more real-time feel. So if that's held down, if it's W, I want the player to move towards the top of the screen. So player pos, get all the typos now, I can't edit these out. Player pos minus, now how fast are they going to move? Well, I don't know yet, so I think we'll add another variable, which is the player speed. Because we might want to tune that later. Let's just default that at something ridiculous. That's probably far too high for now. F player speed. So I want to adjust the Y coordinate. F player speed. Now, whenever we're doing movement, and if you've watched the channel, I'm gathering the people that are here tonight are not brand new to the channel, so you'll know that we use F elapsed time to modulate the movement across the screen. So we've got it going up the screen there, and we'll have it going down the screen. Down being positive, of course, when we hold down the S key. And we probably want the same for the X axis as well. So that'll be the A and D keys. A and D. Oh, D. And instead of Y, we'll change those by X. Very nice. So very simple. Have I got that the right way around? So A is going left, so yes, that's going to be reducing the value. I'll just have a quick glances at the chat. Fruit pastels or jelly tots? I really do like both, but I think, I occasionally want to treat myself to jelly tots. So that's an exceptionally British thing. Right. So now I've got the player movement, let's just draw the player. And the reason I'm showing this first is it's also a nice demonstration of just how simple we can do things using the Pixel Game Engine. So we'll basically have, in our main loop here at the top, we'll have user input. And you know what, we'll flag these as input. In the middle here, we'll have all of the mechanics and movement. I'm going to call those, oh, not that. I'm going to call these gubbins. Ooh. Just got a subscriber via Twitch. Thank you, Lord Chrissy. Thank you very much. We'll have gubbins for there, and then we'll have display at the bottom. Gubbins is an English word. I'll let some of you look that up. Oh, hey Gareth. Hi, nice to see you there. Right, what was I doing? I was drawing a ship. I got distracted there by a subscriber on Twitch. So I'm drawing the player, and that's very simple because it's just going to be drawing the sprite at the location that we've just been creating. So take the vPlayerPos variable, and I'll give it this sprite for the player. And I'm not going to scale it or anything, so that's it. So I think right now, oh yeah, we'll do one thing. Before we draw the sprite, we'll also clear the screen. Now we're going to be in space, so that's very simple. We're going to clear it to black. Oh, thank you very much, Gareth. It's good to see you again, Gareth. Right, so let's just compile that, make sure we've got everything set up correctly. So all I've done is create a standard Windows, this is a console mode application, but it doesn't need, yeah, it does need to be a console mode application, I think. And it just include the Pixel Game Engine header file. I've gone ahead and included a few standard library files, which I know I'm going to be using later on. So let's just see, what does this look like? Oh, already nothing at all, and that's because my player has not been initialized to somewhere useful. So I'll initialize that to here. I'll put him roughly in the middle of the screen. So I'll have screen width divided by 2 and screen height also divided by 2. Don't need the bracket there. vPlayerPos has been initialized. We've got movement. Player speed might be far too high, but we'll see. vPlayerPos, we're drawing them. Okay, let's have a look. Oh dear, first error. Ah, that's because I know, yes. This is something that started to frustrate me a little bit. Is the C compiler has become very, very trigger happy about casts like this. So we might see a lot of casts tonight. Why can't I see a ship? Ah, have I not called... Ah, loading up the wrong sprite. That's probably not going to help, is it? Where is my sprite? GFX 100K player. It's not player 1. Ah, that's what I've done wrong there. Oh, great start. Here we go. It's the beauty of editing videos. There we go. So we've got the player sprite, and I'm moving him around with the WASD keys. Now I don't want the white rectangle around my sprite, so I'm going to tell the Pixel Game Engine to draw the sprite using mask mode. So we just set that. That's set pixel mode. Oh, we'll see. Pixel mask. And what that's going to do is any pixels that have any transparency, it's not going to draw them. So it's faster than alpha blending, but a little slower than just drawing the sprite normally. So whenever you change the pixel mode, it's always good to set it back at some point too. So that should just now give us our nice sprite outline. There we go. Perfect. Got some movement on the screen. Right now we can't really tell what's going on. Now I think to give sort of a bit of context here, so we can see in the background that things are actually moving, I want some something in the background that moves, so we can look at the relative movement between the ship and the background. And I'm going to do that using some stars. So I'm just catching up with some of the chats here. They are going a little bit quick for me to keep up with, so I'll just occasionally glimpse, and hopefully we'll be lucky. I mentioned before that all the chats are recorded in the video, so I can go back and have a look at that, and I will read them all. I'm a bit strange like that. Right, so we're going to add some stars to give the impression of movement, and I'm going to create an array of stars, and very unusually, because people shout at me now for not using Modern C, I'm going to use standard array. And all of my stars are also going to be 2D coordinates. And I'm going to have, I don't know, 100 stars maybe, we'll see. Let's call that array stars. And I'm going to initialize this just with random coordinates for the most part, because I don't know where my stars are going to be. So I'll do this initialization in onUserCreate. So let's do that here. I'm going to use a little auto for loop through my array of stars. That's one of the advantages of using the standard array. And just set the value to some random number based on the screen dimensions. Now I'm going to have to use I'm going to use rand. I'm not going to get stuck into all of the complexity of finding a Mersenne twister and all that sort of nonsense. So what I'm going to do is just rand the screen width, rand mod. That's what I need to do. Rand mod the screen width. There we go. For the X, and we'll do the same for the Y. Just making sure you can see these things on the screen. Yes, you can. I'm not coding in an area that's covered with overlay. So we'll have rand mod screen height. There we go. So a single line there will iterate through all of my stars. A little red wiggly. Why have I got a little red wiggly? I messed up my brackets. Oh. Because I didn't call it S, did I? There we go, S. Perfect. So hopefully that should have now created a whole bunch of stars in random locations on the screen. So let's draw the stars, and we're going to draw them behind the player. So to draw our stars, you know what, we'll just use the same thing again. We'll take our auto, little range loop there, and for all of the stars we're going to call the draw function, and the pixel is just going to be white. So I think that's all I need to do. Yes, very simple. Because now the draw routines actually take in the vector type as one of the standards. So does that give us some stars? It does give us some stars, but there's not enough of them. I think we need more stars. So we'll have 1,000 stars. Why not? See what that looks like. That's better. It looks a bit more like what I need it to be. So we're drawing some stars, but they're a bit static. I want them to move around. So let's make them move around. So I'll just I'm keeping the logic and the update for everything quite distinct at the moment. And the reason for that will become more apparent later, because there will be some times where I want to update the physics and perhaps update the stars at the same time. So for now, do you know what? Actually, no. I'm going to draw. I'm just. What am I doing? I want to draw the stars. I'm going to update the movement. Yeah, okay. Why not? The stars. They're not going to be involved in any of the collision detection, so I may as well just do them at the same place. So I'm going to want my stars to move. So basically, it's an auto scroller. You're always going to be scrolling upwards through the universe. So I'm going to want a speed at which the universe is moving. F world speed, and I'll just pick a number for now, 20. And so I want all of my stars to scroll downwards by that speed before they get drawn. So I could just do it like this. All I want to do is alter the y coordinate because the x coordinate can stay in the same place. So if I do that by F world speed times F elapsed times, that will update the y coordinate of the star. The problem is they'll all fall off the bottom of the screen and we'll never see them again. So instead, I want to check for when that happens. So if the star has gone off the bottom of the screen, so we'll just check by comparing it to screen height, and we're probably going to need some casting in here. Then we'll choose a new x value for the star. I'm just going to borrow this line of code up here because we've already got it. Choose a new x value for the star, but I'm going to set the height to be 0. Just double check, yeah, that looks sensible. Let's have a look. So all of my stars start scrolling down, and when they fall off the bottom, they get a new x coordinate, and it looks like fresh stars. And this stops us seeing sort of repeated patterns in the stars in the background. So that's quite nice. it looks a little flat, so I think what I'm going to do is try and add some pseudo depth to it. Hopefully you can see these stars coming through, because I'm only streaming in 720p. Because I don't have the best internet in the world, and I don't want the streams to be too blocky and stoppy. Okay, so I want to add some depth to that. Now that means if we want depth, basically the stars are further away, I want them to move a little slower. So I need to choose a proportion of the stars to actually move slower, which means I can't really just iterate through the loop in this way. I need to do it slightly more old school. Because I want to know what the index of the star is. And basically what I'm going to do is choose, say, the first 100 stars are going to move at a slightly slower speed than the second 100 stars. So in order to do that, I need the index for the stars. So let's size t I equals 0. I is less than our array of stars dot size I plus plus. And we'll grab a star. Because I like just working directly with it, we'll use a little auto reference here. Yes, auto reference here. S equals our array of stars, element I. Basically, we're just duplicating what the loop was doing before, but now I know which element numerically I'm working with. Because now I can choose a different speed for certain stars. So if I'm working at, let's say, the first 100 stars. That's what I'm trying to think through in my head. So the first 100 stars, I want them to move slightly slower than the remaining 100 stars. Okay, getting there. So let's just bias our speed here by the I value. So if our I is less than, let's say, the first 100 stars, if that's true, then I want to move those a little bit slower than all of the others. Which I'm basically slowing it down because I'm multiplying it by a number less than 1. So if I'm not slowing it down, I want them to all be the actual speed we specified before. So let's just see how well does that work. Well, there's certainly sort of a depth characteristic there. Maybe not enough stars. Maybe we want to change that to 200 instead. Or say 300. Let's be optimistic. So that, to me, adds a little bit more depth to what's going on. Might also help to shade the stars a slightly different colour too. So based on the same equation, I'm going to choose a different colour. So if the ones that are moving slower, then I'm going to use OLC grey. So they're a bit further away, they're not quite as bright. Well, so I'm going to use OLC white. Ooh, capital OLC. OLC white there. Let's take a quick look. That's a bit better. To my eyes, at least on my screen, that looks a little bit more distinctive. Right, so we've now got a ship flowing through space, flowing through space, and we've got something in the background that suggests that we're moving. And the nice thing is we can change the speed of this movement by changing this value. So if I wanted to move everything at twice the speed, it's all relative to what is our world propagation speed. There we go. So a little bit quicker this time. Make the deeper stars fade a bit. Well, I could make them a slightly darker grey. Do I have that as an option? Do I have a very dark grey? Yes, I do have very dark grey. And there we go. So stars in the background look quite distinctly different now. Maybe that's better actually. Yeah, I prefer that. Right, whilst we've got loads of people here, I'll just repeat some of the announcements I made right at the start. There is a prize draw. There's a link below this video. There are 4 £25 Steam vouchers up to grabs. A big thanks to everybody that supported the channel this year, because you know, it's been a fantastic ride, certainly, and the community has just got stronger and stronger. Not specifically around me, but specifically around the idea of helping each other to code, and I think that's the really important message to deliver. Right, we've got stars. Stars are done. So now I think we're on to the slightly more interesting stuff. How do we construct a level in this world? Well, we need to have a think about what we've got going on in the world, and perhaps pull up some OneNote. So sorry for just blinding everybody there. We'll have some slides, and we'll see if this works. Right, yes, definitely. See, completely bleached out my face on the camera there. So when we've got, I'm going to draw these sideways because it gives me a bit more space, but so we know that we've got our little ship here. Try not to make this look too rude. So that's our ship, and that's going to be flying through space, and we know that what we're going to encounter are enemies of some description. And the idea is that the enemies are going to shoot out bullets, and the player is going to have to avoid the bullets and shoot back. Now, how would we normally... OneNote doesn't have a dark mode, I don't think. How would we normally go about setting something like this up? Well, usually when I write games, nearly all of the videos I've done so far, everything tends to be tile-based. So you perhaps have a huge world and you'd allocate a specific tile to be the enemy, and because we're moving through the world, then the enemies don't really move, they'll just propagate towards the player. So that having a tile-based system is probably going to be too restrictive. The second option could be to have the entire world simulated all the time. So all of our objects could have an X and a Y coordinate, and every single frame, every object is updated depending on its movement pattern, because I think it'll be a bit boring if everything's just moving in one direction. You know, we want things to sort of move strangely, like this perhaps, or you know, we have one that comes in and then moves across the screen, or perhaps another one which does some sort of crazy movement just to confuse the player. So we know we've got different types of movement that we require. And I don't want to be updating all of these movement characteristics for every single object, because most of the time we're never going to see them. It's a waste of processing resources. And given that I suspect what we're going to really want is millions and millions and millions of bullets, physics may start to become a resource that we need to look after. Because we don't just want the enemies firing in a boring straight line, we want them firing in all sorts of crazy interesting patterns. You know? So spirally bullets, pulses of rings of bullets that come out, some way to make the challenge for the player. So for all of my objects that are going to be considered enemies, I'm going to want something that defines how they're going to move around the screen, and something that defines what the firing pattern is, as well as what they look like and how much health they have and other things such as that. But I want this to be really flexible, and that's really what this video is going to be about. How do we make a flexible framework that people can extend really easily? Because I know there's going to be a handful of people coding along, and after this video a lot of people might also have a go at implementing something similar. It'll be great to see just how crazy some people can come up with the patterns. So we're not going to be using a tile-based system. I'm not going to be simulating the entire world all the time. What my approach is going to be, I'll just get rid of those. Instead, what I'm going to have is a list. And I'm going to have all of my enemies in a list. I'm just trying to work out on the hoof here how I'm going to visualize this in OneNote. I'm not quite sure. So as the player is scrolling through the world, now this is always going to happen, we know where we're up to in world. We can basically keep track of that coordinate. Where are we up to? And the idea is we're going to have a big queue of different enemies. So these are all going to be queued up one at a time, and they're all going to have a starting trigger time, and they're going to be in order, of course, and that means when our world time, call that WT, is equal to or greater than the trigger time for the object at the front of the queue, then the object gets entered into the game space. Because there's no point in simulating the things that we can't see on the screen. Not necessarily. We might just make this appear slightly before it becomes on the screen so it can scroll into it nicely, but the idea is we'll have all of these things stored in advance. But that doesn't tell us what we're storing. So we know that for each enemy, we're going to want to have something that defines its movement. We know we want something that defines its fire pattern. We know we want something that describes what it looks like. And we know we're going to want something that defines its health and other characteristics. Yeah, ooh, it's a strange E, isn't it? Other sorts of characteristics that we might want in our enemy. And I want to be able to sort of set these up very easily. I don't want to have to create a bespoke level editor or anything like that in order to do it. So what I'm going to do is create a framework which allows us to construct these objects in this queue, and the game is really just playing what is going on with this queue. And that might sound tremendously dull, but as with most games, really the stuff that goes on behind the scenes is not as good as the stuff that happens on the screen. Right, I'll stop blinding you all with that. Just have a quick chat catch up. So hello to all of those people that have joined. Quite a lot of chat going on. It also gives me a chance to have a mouthful of water too. Oh, that's better. Yeah, you'll be picking up all sorts of ambient sound today because I've got my mic slightly lower, so I've got the amplifier turned up a bit higher. It just keeps it out of the way whilst I'm trying to do this. So, what we've just described is that we've got something that defines what an enemy is. And so I'm going to create a structure which will be our enemy definition. There we go. And our queue will store all of these enemy definitions, and when it's ready to turn them into enemies, well, we'll do just that. We'll have a different structure called enemy, which is the on-screen entity doing its thing, and it will be defined by what is in this enemy definition. So we said that we know that the enemies are going to happen at a certain point in time. So the first thing I'll add is a variable that is our trigger time. I'll just default that to 0. So when our world time catches up with the trigger time, we're going to convert this enemy definition into an enemy. The enemy definition needs to tell us what the sprite looks like. So I'm going to use a uint32 for this. I've only got 3 sprites for this particular video, but that's going to be our sprite ID, which now is probably a good time to actually load those sprites. So I'll create a small array of sprites, sprite star that is, SPR, enemy, and we want 3 of them. Let's go down here and load those. We'll just do some vertical cursoring. Enemy 1. 1, 2, and 3, and these are also going to be sprite enemy. Ooh, don't start counting at 1. There we go. 0, 1, and 2. So we've got now 3 enemy sprites loaded in, and we're going to represent each of those sprites with this identifier, this end sprite ID. Other things that our enemy might have is some health. So we can reuse the same enemy sprites, but sometimes we might want them to be stronger or last longer, whatever, don't know. We also need something else, and that is, where does the enemy actually appear on the screen? Well, we know for the Y coordinate it's always going to be at the top of the screen. That's where the enemies are going to come in from. But the X coordinate can change, and that will allow us to have patterns of enemies. So I'm going to include another variable here, f offset. And this is going to be a normalized variable into how far into the screen along the x-axis should our enemy appear. So if it's set to 0, it's the far left. If it's set to 1, it's the far right. If it's 0.5, it's in the middle of the screen. So that's going to be a normalized value, and that just allows us to make the game a little bit less resolution dependent. I'm just going to catching up with some of the discussion here. Can the OLC sprite load a PNG? Yes, it pretty much only works with PNG files. This isn't the console game engine, this is the Pixel game engine, slightly different. So we know our enemy definition will eventually get turned into something called an enemy. So I'm going to create another struct called enemy, and I don't want to lose this definition. When I create the enemy, I'm going to copy this definition into what the enemy is. But our enemies have a position in space, so we'll give these a vector for themselves called pos, and we'll give them the definition. Enemy definition. Def, we'll call that. And I'm going to make it so that the enemies are somewhat responsible for updating themselves. So rather than me having to manually sort of check what the enemy is doing, it's going to be responsible for looking after its own physics. So for now I'm going to create this placeholder function which will pass in the f elapsed time value. We'll come back to this and probably add a little bit more to it later. Now we said we're going to store all of these definitions in a queue, well, a list in this case, and we're going to be using lists quite a bit. So I'm going to create a list, and it's going to be of the enemy definitions. And I'm going to call that list spawns. I'm just going to make sure that that's what I called it before, because yes, list spawns, that's good. And it's going to be this list that defines what our level really is. So let's have a look at how we would go defining the level so far. So I'm just going to use an initializer list. Now you could wrap this up in your own function to go and create bespoke levels in the case of a reset or whatever, but for now I'm just going to assume that once you've run out of enemies, you've run out of enemies, and if you get killed, well, we're probably not going to get as far as implementing death, but we'll see. So for each type of enemy that's coming into the game, I want to populate this SEnemy definition structure. So I can see here that the first element that we're going to add is how long before, and I had to do some experiments on this, so I'm just going to grab some numbers so we're not too busy looking around later on. How long before do we start the enemy appearing on the screen? In this case, it's going to be 100. It was a double, wasn't it? It wasn't a float. It's going to be 100 sort of game units before the enemy appears. So this is not necessarily time, but it's more sort of this artificial game unit world position location. And we're going to use give it a sprite ID. That was the next parameter, wasn't it? Yep, sprite ID. We'll give it some health. That was a float. And the last one, where do we want it to appear on the screen? Well, we probably want it to appear halfway along the x-axis. Oh, don't put the semicolon in there. So we've got a single enemy in our list of enemies. We need to work out where on this list we're up to in our world now. And that's quite easy, because we've got our world speed here. I'm going to create another double value called our world position, world pos. And we'll default that to 0 to start with. But every frame update, the world pos changes. We've got f world speed times f elapsed time. So this auto scroll effect has the effect of continuously moving through the world, and it's going to slowly increment our world position. No, Luby, a list it's not quite an array, no. So now we've got this permanently increasing world pos value. What we can do is compare that with the items on our queue and see if we need to turn any of our enemy definitions into enemies. And there might be several enemies all at once. So I want to check first of all that my list of spawns is not empty. Because if it's empty, then there's nothing left to do. So if it's not empty, and our current world position is greater than or equal to whatever is at the front of our spawn list, then I'm going to convert this definition into an actual enemy, which means we need a new list. We're going to be using lots of lists. And we'll have, this list will be of our enemy structure. List enemies. Lost my place, there we go. So if we want to create a new enemy, fine, that's what we're going to need to do. E we'll call it, and we want to just copy over the definition to begin with. e's.def equals the current front of our list. So list spawns dot front, just copy that over. It might be a little bit redundant, some of the information on there, but it's just going to be at the front of our queue. Now we want to set the enemy's position. So we know that it's always going to have the Y value set to the top of the screen, but the X value is going to change a little bit. So I want to set up this is an OLC vector floating point vector 2 type. So the first one is going to be our X axis. So I'll grab the definition. You know what, I'll just grab the e.def dot f offset times our screen width. So that's taking that normalized offset and putting it somewhere in screen space. Don't need that there. There we go. That's for our X coordinate. You know what, I'm going to just split these out over a couple of lines so we can see the difference between X and Y. And our Y coordinate is always going to be 0, 0. Although it's probably best not to set that directly to 0, 0, or else the enemy will just sort of pop in at the top of the screen. So I want to take the height of the sprite that we've loaded and subtract that. So we've got our sprite array of enemies. We know that we've got our e.def.id. Yes, sprite ID, even better. So that's going to, we can get the height from that sprite. And that's all we need to do. So that means the enemy's not going to quite pop in from the front. So I'll just convert that over to a float. Which, whilst I'm here, is now making me think, well, the X position is probably better if it's not the top left of the sprite. Instead, we probably want to set it to somewhere in the middle of the sprite, don't we? So it's that offset, and we'll subtract from all of that. Oh, come on. Do the same sort of thing. Sprite enemy, but this time we want the width divided by 2. So yes, that will put us in the middle of the sprite. Definitely going to get some casting problems shouting at me in a minute. So we've set the position for our enemy. Once we've got it off the front of our queue, we can simply pop it off the front. We're done with the definition, but we now need to add the enemy to our list. List of enemies dot push to the back E. There we go. Right, so now we've got two things that we need to think about. We've got our queue, which will spawn our enemies when we get up to them in the world, and we also need to think about how we can display our enemies too. So let's go down to where we're drawing things. The enemies themselves are going to also have alpha components, so we probably do want to stay within this masked section, but we want to draw all of our enemies. Let's do that. So this is going to be for auto E and list of our enemies, draw sprite, The position is of course e.pos, and the sprite will be sprite enemy e.def.enSpriteID. So that allows us to make sure we're drawing the sprite associated with that enemy. Very nice. Now, so far, all that will happen is our enemies will pop into existence. They need to somehow move, and that's what we've not got yet. We've not included how do our enemies move around the screen. Tell you what, I'll just have a mouthful of water because I can feel my throat going. This is C++. Just catching up with some of the chats. Quite a lot of chats. It's good stuff. Don't forget there is a prize draw. You can win £25 Steam vouchers. Just enter the prize draw. There's a link below the video. So now we're going to get to the fun stuff. How do we implement the movement and firing patterns? Because so far all we've said is at a certain time after the player has started, an enemy ship has popped into the screen. That's all we've got. It doesn't say anything about how the enemy ship moves around. Well, this is the bit that I wanted to be kind of extensible, because I think it'll be fun for the community to take some of this code and go away and create the most extreme and crazy shoot-'em-up games you can think of. And I'm going to use something which is a little unusual perhaps on our channel, but I'm going to use some modern C++. I'm going to use the standard function type. So instead of what you might normally expect me to do is go and create different classes and use polymorphism to sort of encapsulate all of this movement behavior, I don't need to do that really. All I want to do is have a function associated with the movement and a function associated with how the enemies fire. And when we need to update the enemy's position, we can call that function, and that function will represent that movement pattern. So that's why we've got this sort of little update function in here. And I'm going to, instead of just having a big switch case statement in this update, I'm going to allow us to basically link in a function that describes the movement directly into the enemy. So in my enemy definition, I'm going to add a standard function pointer, and the type is going to be it's going to return void. Doesn't need to return anything at all, but it's going to take in a reference to the enemy itself. Now we'll just need to forward declare that enemy up here. Enemy, there we go. You can take in a reference to the enemy that's currently being updated, and I'm going to pass in some additional parameters. I just want to make sure I get the order consistent with what these parameters are. Right, so they're going to be the elapsed time, because that's what we needed down below. And I'm also going to pass in the current world speed that we're moving around at. And I'm going to call that scroll speed. Oh, I'm doing this wrong, aren't I? These are just going to be floats. So we've got these two floats. There we go. So I'm going to pass in a lambda function that represents this particular movement type, and I'm going to call that funcMove. Not that it moves in a funky way just yet. And when we update the enemy's position, all I need to do is call the definition that we've associated with that enemy and call the funcMove function that we've associated with it. In which case it's going to be the enemy, and then it's going to be the elapsed time that we've passed in here. And I also need to know the scroll speed. Because the world is scrolling at a speed that we've chosen, it's no good letting the enemies just move around not knowing that speed, or else they won't move relative to the rest of the game. So I want to include this scroll speed parameter too. Scroll speed, and that's going to also have to come in through our update function. Hopefully when we start visualizing things in a minute, this will make a lot more sense. So I've got my update. When we're going to loop through the list of enemies, we're basically just going to call their update functions, and they will look after themselves regarding movement and firing. But right now we're just dealing with movement. So let's have a look at adding in a very basic movement function. I'm going to define these movement functions in my onUserCreate function. So I'm just going to stick all of that loading code and prep code up there. We'll keep the list of spawns down here, and in between I'm going to have some lambda functions, and these are going to be our movement patterns. And they're going to look very much like what we've just defined, rather conveniently. So auto, and we'll prefix these with move, and this one will just have move none. So I think it's important that we have just basically go with the flow, travel down the screen. So that will be movement none, and basically it's just going to move in a straight line down. A bit confusing. You've got to remember the world is moving all the time behind the scenes. So if we want the enemy to move at the same speed of the world, it's not actually needing to move at all. So that's why we're calling it move none. And this is going to take in a reference to the enemy. It's going to take in the F elapsed time, and it's going to take in the scroll speed. Oh, that's not how you define a lambda function, David. There we go. I'm just going to cheat and we'll capture everything for now. I'm sure the purists out there can shout at me on Discord later. So if we've got no movement, but we want the enemy to move relative to the rest of the world, then we need to update its y coordinate accordingly. In this case, it's just going to be f scroll speed times f elapsed time. Simple enough. So how do we associate this pattern with the enemy that we've created? Well, here we've got our enemy. It's going to be spawned at that location. But let's pass in, because in our enemy definition up here, the next parameter is this move function. So I can now define this in here, move none. So if you didn't know you could wrap up lambda functions like they were variables and objects, well, you can. So that's going to associate with this particular instance of this spawning enemy this movement pattern. So I think we'll try and start to visualize some of these things now. So once we've emptied our queue of anything that's relevant, so all of our definitions that have just become enemies, we then need to start updating some of the physics of what the enemies need to do. Now, consult my prototype here. Let's make sure I'm getting things in the right order. Yes, very good. So we'll now update the enemies. And the nice thing about this approach is everything slowly becomes one-liners. So for auto, we want to get auto reference E, list of enemies. We just want to update them. So E, update. We'll pass in our F elapsed time. And our F scroll speed, we actually called it something else, didn't we? We called it world speed or something like that. Yeah, F world speed. I'll just run with it for now. So we pass in those two variables. That's going to update, not to bother, but let's walk through it. So we'll go through each enemy in our list of on-screen enemies. We'll call its update function, which was defined here. The update function then calls the movement pattern function that we've associated with that enemy, and hopefully it should move around on the screen. Let's just take a look, take a deep breath and take a look and see what happens. If we've not got any bugs, that is. So we said it will come in at about t equals 100, and there it is. You see it came in from the top, and it's moving relative to the rest of the world. Enemy exists, and enemy has now gone off the screen. And this is an important thing to think about, because the enemy has gone off the screen. It's still there, but it's absolutely no point in having it there. So we should probably look to purge our queue of enemies which are no longer relevant to the gameplay. So we will remove enemies that are redundant. Sounds like a good comment. And to do that, I'm just going to use the remove if function on the list. So if our list enemies dot remove if, and we're going to base this on a condition that the enemy has gone off the screen. So we'll just capture everything again, cheap and cheerful. This will take in a S enemy reference, spell enemy right. E, that's all that's going to be in there. And what we're going to check is just to make sure that its coordinates are still on the screen. So if the Y position, which is at the top of the sprite, if any of these return true, it's going to remove this enemy from the list. So if e.pos.y is greater than or equal to screen height, and I'll stick the cast in there, then it should flag that enemy for removal. Are there any other conditions we might want to remove an enemy? I think there are, because, just trying to think ahead here, our enemies, where did I define them? Our enemies have health. So if we shoot the enemy and its health goes below 0, we also want to remove the enemy. So let's stick in that condition as well. So we've got sort of two conditions for removing an enemy from being on the screen. I'll just use a logic OR for that. So if the enemy definition dot health is less than 0, less than or equal to 0. Yeah, that's everything I need, I think. So we're updating our enemies and we're removing them if they're off the screen. Let's just add a few more enemies in different locations. Tell you what, just to make things happen a little bit quicker, I'm going to start that one off at 60, and we'll show you why this method becomes very flexible now. So let's add 2 more enemies. Let's add another 3 more enemies here. Just indent those. So this first one's going to appear at whatever 60 happens to be. Let's put the next one at 120, and let's put the next one at 180. They'll all be the same. Well, let's vary the graphics up a bit. So the next wave will be those, and then these will be these. And we'll adjust these positions. So for this one, I want this to appear at quarter and about 3/4 along the screen. These ones will have at, I don't know, 0.2, 0.5, yeah, and 0.8. Why not? So sort of in the middle. So we've now defined a whole bunch of different enemies, and we'll see why this way is nice to define a level. Just make sure, yeah, okay. Multiple enemies. So what we should see now, hopefully, is a little bit more interesting. So there's our first enemy appearing, there's our second, and there are our third enemies. They're a bit close together, so we probably want to space out those timing intervals. But we've now got a way of defining whereabouts in our level those enemies appear. So yeah, I am going to space those out a bit. You know what, well, we should probably double them a little bit. Yeah, 240, 240, 360. 360, 360. Just see if that feels a bit better. Whilst that's compiling, hello to everybody in the chat that's joined in. Thank you for coming along. Thank you for making this year really good fun. That looks a bit more sensible. So now our enemies are scrolling, but they're scrolling a little bit boring, right? You want the enemies to do something a bit more interesting. So let's add in a slightly different movement pattern, perhaps. But I'm sure at the moment you can see that right now we could have a big long list that represents everything that's relevant in our level, and we're actually saving processing time because we're only ever bothering with the things that are on screen at any one time, and the framework is sort of taking care of that for us, which is quite nice. So I'm just going to consult. I created in advance a whole bunch of different movement patterns, but I don't want to go into all of them, I think, during this stream. So let's say we wanted something to move a bit faster. So this is a nice one. So let's take another Lambda function, and we'll call this one move fast. But all it's going to do is move fast in a straight line. This is exactly the same as the one before, but it's going to move 3 times faster. So let's do that with our middle two here. So instead of giving them the move none pattern for movement, I'm going to give them the move fast. So we'll see our first one appear, second one appear, but they have their own unique movement pattern, and the third ones appear. So everything's under control about when the enemies appear, so you don't just end up with this big cluster of enemies all at once at the start of your level. And it becomes quite a flexible way of doing things. So hopefully now you can see we can easily start adding in more and more movement patterns. There are some problems, and we'll address those too before the end. But let's add in something a bit more fun now. Let's add in some firing patterns. Maybe also ridiculous and ludicrous speed. we could have some insane modes later on. I'll leave that up for you guys to do. I will try and make sure that the source code that we hacked together today is available straight after the stream anyway. Usually I'm a little bit lazy regarding that. So we'll take a very similar approach, but we'll add in some firing patterns. Now this means we have to add in a few more objects yet, because we're not quite done. Ugh. Going at a good pace, I think. Yeah, a good pace so far. Right, okay, bullets. Bullets are a little bit more interesting because bullets need a direction as well as their current position on screen. And they also need the ability to be consumed. So if a bullet hits the player, it needs to disappear. You don't want the bullet to hit the player on successive frames, or else the player doesn't stand a chance. We also, in the same way as we have the enemies, we need the bullets to be able to come off the screen. So I'm going to add in another struct that's going to define a bullet. And that's going to consist of two vectors, vf2d pos, which is going to be the position. We'll also have another one, which is going to be the velocity of the bullet. And don't forget, velocity includes direction, it's not just speed. And I want to include a boolean in there, which is going to be a remove flag. So at any point we want to command the bullet to no longer exist, we'll set this flag to true, but by default we'll set it to false. And as we had with lists before, and this is, I don't know if Diego is watching, but if Diego, if you're watching, and the other day you said there's absolutely never a reason to ever use lists, well, here we go. S bullet, and we'll call this one, unsurprisingly, list bullets. There we go. And so, like with our other start again. Like with our other objects, our enemies and our player, we're going to need to update our list of bullets, and we're going to need to draw our list of bullets, and we're going to need to remove bullets that are no longer relevant. So this list of bullets is going to be quite an important thing, and we're going to maintain a separate list for enemy bullets and player bullets, and we'll talk about that a little bit later when we implement player bullets. You just find where my update enemy bullets are. There we go. So updating enemy bullets is a little bit more tricky because we also at this point probably want to start thinking about how they interact with the things that they touch. But for now, we'll just create another little auto range loop here. Auto, call it that, list bullets. And updating the bullet's position is really simple because we just want to take our position and we want to offset that by the velocity for the current elapsed time. So b.vel times f elapsed time. If I've missed notifications, I am sorry if I've missed them. I've got to keep this quite quiet or else I get lots of feedback. Now, our bullet's velocity, we can't just update it by this velocity on its own because there is another velocity in play here, and that is our constant scrolling world. That's always in effect. So we also need to include that in here too. Unfortunately, that's very simple to do because we could just construct temporarily a vector that contains that velocity in the y direction. 0, 0. And what did we call it? F world speed. There we go. So we'll take the bullet's current velocity, add it to our auto scrolling velocity, times that by f elapsed time to sort of give us the integral movement. And that's it for now. We can come back and do some checks later. So again, pretty much a one-liner. But in the same way as before, we want to make sure that we've not got lots of bullets we don't need. So I'm going to remove bullets off screen. Oh, thank you, Ollie. I've got a new thing there. I've not seen that before. Thank you very much. Yes, tea. I could really do with some tea. I only prepared myself with some water. Right, so this time we're going to remove our bullets in a very similar way as before. We removed our enemies, so nice that this remove if function exists. You'll notice I've not created any pointers anywhere, so we're quite happy just removing things from the list. That's no longer an enemy, that's a bullet. But the check is a little bit more involved this time. So we want to check, firstly, if we're off any side of the screen. Oh dear, come on. b.pos.x is less than 0, then bullet has gone off to the left of the screen. Or b.pos.x is greater than screen width. And we need to do something comparable for y. So take b is greater than screen height. I think I've already got that there. Perfect, that's good. Or b.pos.y is less than 0. So I'm basically just checking, is the bullet outside of the visible area of the screen? I'm also going to throw in, and I know this is right at the edge of the screen here, so sorry if I'm not moving the camera around. I also want to throw in the equivalent of the health for the bullet here. We had that remove flag, don't forget. So if at any point we cause the bullet to be no longer required, that's where we're removing it. Probably got brackets errors all over the place. There we go. Let's take that out. And we didn't call it B. There we go. So just double check that that makes sense looking at it. So yep, screen width, screen height, 0 and 0. And we're removing. Jeremy, thank you very much. That's very, very kind of you. Very, very kind indeed. Jeremy Smartwood there. Much appreciated. Well, it's a shame. I mean, the VOD will be available, and I thank you very much for that. All donations and things end up in some way or another going back into the community, either through new gear from me to make better videos, or interesting technology that I can make videos about. So thank you very much. Yes, $50 for using lots of lists. Lists of the future. I appreciate that, Jeremy. Thank you very much. So. We're completely distracted now. That's the downside to getting a very nice, generous donation like that. We've removed bullets off the screen. We've updated the bullets' position on the screen, but we've missed out something fundamental, haven't we? We've not actually got a way yet to include bullets. Is this my full-time job? No, it is not. I do have a full-time job, so I can only do YouTube videos and Twitch streams and manage the community in my spare time. And that's why one of the reasons we're having a party today at the end of the year, because this will be my last video for the year, and it is customary, at least in the last 3 years, that at Christmas I take a little break. I won't be back on YouTube until probably the end of January, something like that. Gives me a few weeks to have a rest and come up with a load of new ideas for next year, and my ideas list is bulging, but I do actually have to work on the code at some point. Would I like it to be my full-time job? Yes and no. I mean, I do enjoy doing this. I'm pleased that people are enjoying what they see and taking part, and it's great to see somebody, for example, join the Discord server that can't code a thing, and within a couple of months they've got their own games up and running, and it's really satisfying to see it just working. You know, from that perspective, I'm pleased that the output is doing what I'm trying to do. Is it enough to sort of feed the mouths I have to feed, or pay the mortgage and all of the other real life problems that we have to deal with? Probably not, so I would need to keep a job on the side as well. I do try and reply to most of the comments. Now the comments get a few too many on the videos to reply to all of them, but if the comment is well formed, I do read them all. I should point out I read absolutely everything that gets sent through. So even if it's on the GitHub, even if you're complaining about some bug you've found on the code, it gets read. It doesn't always necessarily get replied to, but it is certainly acknowledged. I do want to stress that I'm not the kind of guy that's just going to ignore all of the comments on the videos. I'm even still replying to comments on videos from 3 years ago. But it's just now I have to do them in batches rather than immediately respond. So we're up to bullets. Bullets. Let's have a look. I'm sure mentioning bullets so many times is going to get this video flagged in some way or another. So let's see where we're up to with bullets. I'm also conscious that I don't want to take up far too much time either. So bullets, we want another function, didn't we? That's what we were going to do. So we've created a function here for our firing patterns. We're going to want something that's very similar for our firing patterns. I should have said moving patterns before. It's my brain going too fast for the speed of my fingers and mouth, I think. Now, we've only got one list of bullets to play with, and I don't want this function to necessarily return things that then we've got to insert into the list. So I'm going to pass in a reference to the list of bullets, which will pass through all of these functions. Now, there probably is a tidier way to do this, but I just liked the simplicity of this. So we've got our standard list of bullets, a reference to it, and we'll call that func fire. There we go. So now we've got another function. We can go and create, we'll just update this in here too, why not, whilst it's here. So as well as updating our bullets, we also need to update our firing. Forgotten how to type already. Blown away by the donation. Right, update. No, it's not update. They're completely confused now. Dear me, fall to bits. Func fire. Again, we pass in the pointer to the current enemy. We pass in, it's the same parameters. I'm not repeating them. Let's cut and paste those. Same parameters, because the bullets may need to know what the starting scroll speed is, for example. We'll see that in a minute, because bullets can go everywhere, and that's what makes them really fun in this instance. But we also need to pass in our list of bullets, and that's something we haven't got in our enemy update function. So again, I need to bring that in. Just call that B. We'll pass in B there. So that's actually a list of the current bullets. And by passing everything by reference like this, you'll see we're not necessarily using pointers directly. We're not worrying about memory management, but at the same time, the nice thing about using the standard library in this way is it's all sort of self-contained. It's going to look after itself. I've got a little red wiggly there for some reason. Why is that? It's because we've just changed this. We now need to add into here our list of bullets. So that's where we're updating the enemies. We've now given the enemies all the information they need to do their updates. Right, so we need a firing pattern. That's what we need. So let's just copy one of these to start with. And instead of this, we'll call this one fire none, because you might want enemies which don't fire anything. And you could extend that, and we probably won't get around to that today. We could extend that by having other things like pickups or blocking scenery. They could all be built into the same framework. So it's important that we also have a facility for not firing at all. And in this case, if we're not firing anything, we're not adding anything to our bullet list. I just need to include that at the end here, don't I? Standard list S bullet. We'll call that, what did I call it? Bullets. I just want to try and be consistent so I don't get lost later on. Is that actually what I called it? Can't remember. Standard list. Yes, bullets. So firing none doesn't seem to be like a very interesting pattern because it doesn't do anything. But we do need it for things that don't fire. So we'll also have another one straight away. And we'll keep this one really simple and boring. This one's going to be called fire in a straight line every 2 seconds. Let's have a think about that, just whilst I catch up with some water. Right. We've encountered a small problem, and it's to do with state. And that's why I'm just having a little bit of a think about how to sort of elaborate this. Right now, every frame we're calling our update function. So every frame we're updating the object's position, that's fine. But when it comes to firing patterns, we don't want to just add bullets every single frame. We want to sort of store a delay, or we want some sequence of triggers or events or something in order to allow us to fire the bullet. Or else it would just become a screen full of, well, bullets, like in a bad way, not in a good way. So we need some way of having some temporary state information that's persistent between these calls. Now, if this was done in an object-oriented approach, that's fine. In the class, we could store lots of information about the firing pattern, and we'd let polymorphism sort it out. We don't have that option available to us here. But what we can do is, we know that we've got this enemy object. We can associate some basically scratch pad RAM with this enemy object that the firing pattern lambda function can use to do with whatever it wants. Now that might sound a bit strange, but basically we know that our firing patterns are never going to require a huge amount of data. So let's provide a bunch of small amount of temporary variables which are local to the enemy, and that way we can store store information between function calls to the same lambda function. You'll see what I mean when I start coding that out. I've probably not verbalized that very well. And I'm just trying to find the relevant part. I just want to make sure my variable names are the same. So our enemy here, after we've defined the position and definition, we want to associate with this just some temporary storage for these functions to use if they need them. And that's what's going to allow us to do far more interesting patterns, because we're allowing the enemy to maintain its own local state, not some global state. So they won't all fire at the same time. They won't all fire in the same direction. It's going to be quite unique per enemy. And I just want to provide some temporary values. So I'm going to provide 4 floating point values here. And I'll do 4 for the movement function, and I'll just initialize those to 0. And I'm going to do 4 for the firing functions. Now, it's completely up to the programmer, you guys, me, what we do with these. They're just 4 storage locations to store information. So you need to monitor that and keep track of that in your functions. But for example, we want to fire something every 2 seconds. So somewhere in this particular enemy's firing pattern, we need to accumulate that 2 seconds so it knows when to fire. So let's put in a small const expression here, float f delay. So if we want it to fire every 2 seconds, we can put that in here. So that's some information we can tweak later on. But now I've got those storage locations. For the firing pattern, I'm just going to use storage location 0. Like I say, they are meaningless. They're just there. As long as you're consistent with them, that's all they're for. I'm going to accumulate f elapsed time, because what I want to check for is, has my accumulation gone beyond this delay? So if e.data fire 0 is greater than or equal to f delay, now I want to fire a bullet. Not necessarily every frame. And we wouldn't have been able to do that without having this sort of intermediate persistence stored in the enemy object. Let's have a quick look at the chats, because they are flying by on my screen. Is going to teach how to make Super Mario Brothers. I've actually done a video on a simple Super Mario Brothers like thing. So it's called a Code It Yourself platform game. And then if you want to go even further, you can emulate the actual Super Mario Brothers. Why not use statically declared variables instead of a pre-allocated array? It seems that you'll use the array for each firing pattern in a roughly similar way. Yes, I can't create them statically because each enemy might have its own unique set of data. So that's the first thing. So if I'm accumulating this delay, that delay is now relative to when that enemy came into existence, not necessarily all the time. So it does need to be local to the enemy. What was the second part of the question before it disappears? It seems that you'll use the array for each firing pattern in a roughly similar way. Yes, and I understand what you mean there. So it's probably that always will use data fire 0 to accumulate time in some way or another, but not necessarily. That could be completely up to you. There's also another interesting part here, is that you've also got the movement data available to you. Now, I won't exploit that in this video, but you could change the firing pattern depending on current movement states as well. So you could actually end up with different firing patterns being called to give you very sort of exotic behaviors of what the enemy is doing. But anyway, we've now got to the point where we're ready to fire a bullet. So in this case, I'm going to, because I want to maintain the timing to be accurate, you don't just set this back to 0, you subtract from that your current delay, because it's very likely that eDataFire has gone a little bit over what delay is, and you don't want that error to sort of accumulate. So that's a bit better. At this point, we want to create a bullet. Just looking at Gareth's comment there. People are really hating on OOP at the moment. I don't see why at all, but hey, fair enough. Right, where do we fire the bullet from? So in this case, we're firing straight ahead. So the bullet's got to come out of the enemy at the front in this case. So we'll specify the bullet's original position to be the same as the enemy's current position, plus, and we want some offset vector. Now I'm going to cheat a little bit here because I know the sizes of my sprites already. Now this is only to save time and to save me typing out lots of code. In the code I'll upload, I'll probably get around to changing this to be a little bit more flexible depending on the sprite sizes. But to save me interrogating the sprite sizes every single time, I'm just going to hard code in some numbers. So this is bad. My sprites are 48 by 48 pixels. So if I wanted my bullet to appear at the bottom of the sprite, I've got to increase the sprite's height here. So, and offset by 24 pixels to make it come out of the middle. So VF2D, I know it's 24 pixels in and it's 48 pixels from the top. So in my prototype I've actually gone away and made it so it works out what all of these values need to be, but I think we'll be here for quite some time with all of the different patterns that we want to get through. So we've specified where the bullet is going to start from. We also need to give it a speed. Now we've indicated that this particular type of firing pattern is just to fire straight down. So b.vel equals, we want to create a new vector, no x component to the velocity, and we want our bullets to move quickly. 180. Once we've created the bullet, we'll add it to our list of bullets. Spell it right. There we go. So our firing lambda function here will be called with unique data to the enemy that's associated with it, and it will, if necessary, add pre-prepared bullets to our list of bullets for processing later. So now let's just add to, we'll have to add it to, we'll add it to a couple of these. So for this first one, we'll add the firing pattern none. So it's not going to do anything. But for this second, oh, let's do it for all of the others. Fire straight 2, 2, 2, 2, and 2. In this instance, we've now got everything firing except the very first craft that comes along. You know what, we'll just mix it up a little bit. Let's just put in a firing pattern there. We haven't yet drawn the bullets, have we? So we just need to draw them too. Now for my bullets, I'm going to create it very simply. I want the bullets to always be on top of the craft. So they go above enemy craft when we draw them. So it's probably the last thing I want to draw is the bullets. Right. So we'll just go auto, B, list, bullets. And I'm going to draw enemy bullets as little red circles. So fill circle is what I want. Fill circle, b.pos, and we'll give it a radius. What radius? So I don't have to figure it out later on. What radius did I give it in my prototype? I gave them 3. Seems a bit small, but that's what I gave it. OLC red. So enemy bullets are going to be red. And I'll put some comments in here so we can see what's going on. Draw enemy bullets. We've updated the bullets, have we? Yes, update bullets. We remove bullets that have gone off the screen. Do you know what? Let's just click it, see what happens. We'll probably find some bugs now. Right, so the first enemy should come along. Doesn't do anything. Oh, there we go. It fired. 1, 2, 3. So they're firing every 2 seconds. That seems really boring to me. So I'm going to change that to into 0.2 seconds. So every 200 milliseconds they should fire a bullet. Let's have a look. Probably should have made that first one fire. There we go. Now these ones are moving slower, so the bullets have this illusion of being further apart. Very nice. Okay. Let's add in now the ability to, what should we do next? Firing bullets? Player bullets? Don't know. Let's have a slightly more interesting movement pattern, I think. So we'll go back to our movement patterns. Now you can't have a SHMUP without some sort of sinusoidal movement pattern. So I'm going to create one here called move sinusoid, and we'll call this one narrow, because I'll create 2 sinusoidal patterns, one which does like a slight wobble and one which does a big screen hugging wobble. And in order to do this, we're going to effectively take we wanted to move in a sine wave, but each frame I'm only going to know the differential of the sine wave, and the nice thing is the differential of the sine wave is easy enough to calculate. It's what is it? I'm sure one of the maths gurus will come out. It's cos, isn't it? It's minus cos or something like that. It doesn't matter. Ultimately, it's going to look periodic. So we'll set the speed to be slightly slower going down the screen. That's what we want first. But we also we are going to need to accumulate time, because if I'm calling sine or cos of one of these functions and I use just f-elapsed time, the value is always going to be quite similar because f-elapsed time isn't an accumulation. So I'll use one of these temporary data stores that we created for the movement side of it. So eDataMove0 plus equals f-elapsed time. There we go. And I want to adjust the x coordinate of the ship by accumulating the difference between the two the difference of the sine wave over that given f-elapsed time period, but that's easy enough because it just becomes cos times some high speed. So let's pick 50 times cos, and it's the cos of this accumulation. It doesn't really matter what that accumulation is. In this case, it just represents time, but we could change the frequency and all sorts of things on that easily enough. And it's all of that times f-elapsed time, isn't it? Yes. So we've got a narrow sinusoid there. So basically what we're telling it is move down the screen in a sinusoidal way, but have a peak to peak of 100 pixels, because the sinusoid is centered around 0, and it's going to go from minus 50 to plus 50 relative to our starting position of the object. So let's throw that one in. Let's see what we can have. Let's have these two that are moving fast. Let's have these now moving with this narrow sinusoid. Sinusoid, what did I call it? Sinusoid narrow. Sinusoid narrow. Sinusoid narrow. So let's just see that simple change. Let's see how that affects the enemies in the game. So there's the first one, our reference enemy doing nothing at all. Our next ones come in and they've got a slow moving sinusoidal pattern. I'm probably not going to do ship to ship collision yet. We will certainly do bullet collisions, but not ship to ship collisions. So maybe we do actually want those to move at a slightly faster speed. I'm actually a bit concerned why are they moving so slowly. If I put in some sort of slow down factor there, have a look. Or have I forgotten to include the scroll speed? Where is my move sinusoid? Oh, I am actually just telling them to move slower than the rest of the world. There we go. Hey, I can program the game but not necessarily play it. Okay, so now we've got an enemy with a fairly simplistic pattern. Very easy now to create a slightly modified sinusoidal pattern. Let's have one that does some crazy wide sinusoid. And all we need to do for that is up this number. So that's going to increase the size. Now they might fly off the edges of the screen, but that's okay. We only check if our enemies are dead when they've gone off the bottom of the screen. So let's have our very first ship, move none, is now going to move sinusoid wide. And I'm hoping it's becoming apparent that you can see now we can just encapsulate these movement principles and firing principles very simply. So that's nice. The ship is now moving nice and smoothly and doing its own thing. We've picked some very simple things here. We've got the ships just moving in this sinusoid pattern. But because we're storing this local data, we could have for the first 5 seconds it does a sinusoid, and then for the next, after 5 seconds, it flies off horizontally and does all sorts of things. Because we're storing local state with the... Sorry, I'm just reading some of the chats there. Because we're storing the local state along with each enemy object, we never really lose track of where we are. So, next thing to add, let's add a slightly more chaotic firing pattern. I've made a few sort of template ones up here, so I'm going to throw these in. Right, how about one that fires everything out in a circle? That might be quite nice. So I'm just going to copy that one. Fire. I'll call it circle pulse 2. And the pulse 2. The reason I'm calling it that is we don't want it to just constantly fire outwards. We want it to sort of fire with a certain duration. So in this case, let's say every 2 seconds again. So let's set our delay out to 2 seconds. So every 2 seconds, it's going to fire a whole bunch of bullets, because right now we're only ever returning 1, but there's nothing stopping us returning more for simultaneous firing. How many bullets shall we return? So let's include that. Int end bullets. In this case, we'll have 10 going out in a circle. Now, I'm going to have to do a little bit of trigonometry here to work out which direction the bullets are going to move in. So I'll need to work out, if I've got 10 bullets and I want them to move in a circle, what's the sort of radial difference between the bullets. So in this case, we'll have a theta value, which is the angle between 2 adjacent bullets, which is going to be full circle, 159 times 2 divided by our n bullets. Right, so we'll do the same sort of thing for accumulating the delay. We'll use data5. If that goes above the delay, we reset it, but now we want our bullets to be a little bit more interesting. So we'll create int I equals 0. I is less than the number of bullets we're going to create, I plus plus. Oh dear. And all of our bullets this time, if they're being fired like this, they're going to come from the center of the ship. So we don't need to do any offset, but our velocity is going to change. I liked the speed that we chose, 180. That seemed about right for me. In this case, the velocity is just going to be the sine and cos of the theta value for that particular bullet's index. So we'll have cos of f theta times I for you, and the sine equivalent for you, sine f theta times I. So we're giving the bullets a big velocity and adding them to the list. In this case, we're going to add 10 bullets. So which enemy shall we pick on? Well, we've not got anything for this first ship, and we call that one circle pulse 2. So every 2 seconds, what I'm expecting to see is a whole burst of bullets appearing out of the ship. 1. We need to offset it to the middle of the ship. Okay. But that's now, there are firing bullets in all directions. So it's got its own unique firing pattern. So this little this thing, we did actually need a small offset, didn't we? That's top left of the sprite. I want it to be the middle of the sprite. So again, I'm going to cheat and hard code some numbers here. 24 by 24. So that'll be more centralized around it. Let's just take a look. That's better. Maybe the craft is moving a little bit too quickly in this instance. So maybe this sort of firing pattern is better with slightly slower moving ship. But that's easy enough for us to change now because we can simply change this sinusoid pattern into something else. Let's just stick with a none at the moment. Keep that simple. But let's start playing with some of the chaos. We've now got it firing out every 2 seconds. It fires out 10 bullets. Let's make it fire out 100 bullets every 2 seconds. Okay, maybe 100 is a bit too many. So let's just change that to 50 bullets perhaps, and we'll get it to fire every half a second. Hey Ben. Right, that's more like it. There we go. So that one's got some chaotic pattern associated with it. I told you we'll have lots of bullets in this game for you to try and judge. Right, so now you see all the bullets stop and things when the enemy's gone off screen. And if you're looking at the side here, we're absolutely not leaking memory anywhere or anything. We're not doing anything with memory in this program. Very nice. Right, so we now need to add in some form of collisions. We've got bullets everywhere, so how are we going to handle collisions? Well, in order to have a collision, we need to have some health. So, add a variable called player health. And I'm going to set that to hopefully we're back up and running. Are we back? Excellent, good. Sorry about that. Hope that's probably going to split it into 2 videos awkwardly. Yeah, I think we're back. It'll probably pop up for most of you a bit later as we go along. That was the error message I got was from YouTube saying that effectively I'm streaming too fast. It's saying that the bitrate I'm using to upload is too quick. So it it crashed out. Who knows? Someone doesn't like my C-style casting. Oh, okay. Yes, hello. Yeah, sorry about that. I don't know why we suddenly got cut off there, but hey, we're up and running. We were in the middle of drawing a health bar because in order to know if our collisions are working, we're going to have to see if our health is going down. So I'm going to position this in the top corner of the game, and a health bar is very easy to draw. You know what, I'll put in a little colon there as well. I'm just going to fill a rectangle based on our percentage health. And what I was saying before the stream went dead is I've already worked out these coordinates in advance. I just want to try and keep things moving, so I'm just using the ones from the prototype. So it's my current player health value divided by 100 in this case. I mean, we could have done player health being 0 to 1, I suppose. It doesn't really matter. And we'll multiply that by a known width, which looks okay on this screen. That's what that 576 is there. And we want it to be 8 high, and we'll draw that in green. So let's just make a look. Good, so we've got a health bar that goes along the top of the screen. So now we want to work out the collisions for the player. Let's do that. So I'm just looking to see where in my physics am I doing that. I'm doing it after update enemy bullets. There we go. Right, update enemy bullets, update enemy bullets, update enemy bullets. Here we go. So this is the list of the enemy's bullets. And we're updating their position. But we can check to see if they have collided with the player. And all I'm going to do is a simple circle v circle check. So I'm going to assume that the player is actually a circle with a radius, and that's not a bad thing to assume because the sprite is reasonably circular. So in this case, if the bullet's position minus, now we're going to use all of the vector arithmetic tricks here. So if we've got the player's position plus we want to offset it to the middle, because remember the player position is the top left of the sprite. So I want to create a circle around the middle of the sprite. So I'm offsetting it to the middle. I'm going to get all my brackets confused here. If the length of that vector is less than, yes, the player's ship's radius. Okay, because we're creating a, what am I doing? Let's pull up some OneNote here for the collision. Oh, move my glass. So we've got a player bullet coming in, and we've got our player ship. So the ship's X and Y coordinate is there. Just making sure the stream's still good. And our bullet X and Y coordinate is there. We're essentially looking at the length of this line, and if the length of this line is within the radius, then we've got a collision. Yes, it is quite bright, that, isn't it? Let's pull that down. So we've got here a vector that's been constructed. Make sure I get my brackets in the right place. And I'm going to take the magnitude of that vector. Well, I'm not actually going to take the magnitude. I'm going to take the magnitude squared, because I don't need to do the square root, because the player's radius doesn't change. It's always going to be the same. So I can just use that as a hard-coded number. So if all of that length, make sure I get that the right way around. So if that is less than the radius squared, well, we're going to cheat again, so that's going to be 24 times 24. The compiler will sort that bit out for me. If that's the case, oh, I've got a little red wiggly here. Don't know why I've got a little red wiggly here. Ah. There we go. No, nearly. That's good. Brackets. We knew we'd have a problem with brackets. Right, so the bullet has now entered the same circle that the player resides in. So we want to tell the bullet to be removed. We set that flag, so that will now get automatically removed by the rest of the system. We also now want to reduce the health of the player. Minus equals 1. I don't know what these numbers need to be in order to make this a fun game. These things can be tuned later on. So, with that in mind, let's have a fly about. So get hit. Oh, I think I got hit a bit too excessively there. I'm not seem to be getting rid of my bullets. So even though I'm being hit, they're not being removed. Why is that? Oh, be remove equals false. That needs to be true. That doesn't work. There we go. So now when the bullets hit me, not quite. Something's not quite right there. Circle's not in the right place. Let me just double check what's going on with our collision. Boom, boom, boom. So we've got our position minus the center of our player. So the center of the player is that. We've got I think that's where the problem's fallen in, hasn't it? the center of the player being subtracted from the center of the bullet, we find the magnitude squared of that. One, two, three, four, 1, 2, 3. I'm missing one there. Missing one there. Let's try that. That looks better. There we go. Brackets. I hate brackets. So now we can see our health depleting, and we're also sort of consuming the bullets that are hitting us, so they're not hitting us again. Very good. So now we probably want to add in some player bullets. So I'm going to use the same bullet structure, but I'm going to create a different list. And in fact, I'm going to call these, well, we'll just call this new list player bullets. Probably should have called those enemy bullets. List player bullets. And I'm going to have the bullets fire on both the space bar being pressed and the mouse button being clicked. So I want to do that in my input section, don't I? Not down here. Input, input. There we go. So let's be sensitive to those things. If get key OLC space is held, or get mouse button 0 is held. And the reason being is I'm using WAS and D to control the ship. Mouse clicking might feel a little bit more comfortable. So if either the spacebar or the mouse button is clicked, then we want to create a player bullet and fire it. So the simplest option, one of the things I don't want to do here though is fire. I don't want the player to have to sort of go click, 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 click all the time. It's too much. So I do want some sort of automatic firing going on. So I'm going to add in a small timer that allows you to sort of hold the mouse button down and it fires buttons periodically. Fires bullets periodically. So I'm going to call that what my gun reload and gun reload time. So float f gun reload timer and current gun reload, we'll call that delay. And we'll set that to, we can only fire every 200 milliseconds again. That seems to have been a nice round number so far. Let's go down to firing. Oh, I'm going to have a mouthful of water, just hang on. Pixel Game Engine fundamentally is OpenGL in the background. Just catch up with the chat. It's been about 300 messages since I last looked. Oh dear me. I'll catch up with all of these chat messages when I look at the video later. Right, so what we're trying to do now is if we're holding down the button and our gun is ready to fire, so that's the simple thing that we're trying to implement. So we always want our gun timer to be counting. So if we have f gun timer plus equals f elapsed time, we're just going to accumulate f elapsed time, and if our f gun reload timer is greater than or equal to our f gun reload delay, then we're going to set a flag that says we can actually fire. Firing is allowed. And we'll reset our timer. So if B can fire equals true, and B, we need to reset our timer, of course, at the same time. So reload timer, again, F gun reload delay. So it's the same as we were doing before with the firing patterns. In fact, you could extend this to have different firing patterns for the player. So as you picked up different weapons, you could in a very similar way use the same firing patterns perhaps that we created earlier. You just have to remember what direction things are moving in. So in this condition, we're now allowed to fire a bullet. So only if we're holding down these things and if B can fire is equal to true. Because I'm talking out loud in my head, I'm typing at the same time. If we can fire the bullet, that happens quite a lot. Then we want to add a new bullet to our list of player bullets. So we'll create the bullet. We'll set its position, in this case to be the player pos dot x plus 24 because we're coming out the middle. Now the player sprite is the other way round to the other sprite, so I don't need to offset in the y-axis for the player sprite. So it's just player pos dot y. And we'll set the velocity b.vel directly shooting straight up, and we'll have the player be able to fire bullets a little bit faster, I think, than the enemies. Why not? And we'll add that to our list of player bullets. So now we need to update our list of player bullets. We've got to update enemy bullets. We now need to update our player bullets. And of course, it's a very similar thing. So similar, in fact, that I'm going to borrow some of this code. So this is update player bullets. Now, bullets can't interact with bullets. So that's the first thing. You can't sort of shoot another bullet and it disappears. And the reason for that is we've got so many bullets on the screen, very quickly we'll end up with an ON squared problem. There'll be so many collision checks going on, the game will just scream to a halt. So we're updating the position of the bullet based on the parameters of the world and its current velocity, but we do also want to check against all of the enemies that are currently on screen. So let's just throw in another auto here, list enemies. So for every bullet that the player has fired, we're going to test it against all of the enemies. There's probably a way to optimize that a little bit more. But instead of checking against the player position this time, it's just going to be the enemy's position. All of the enemies are also 48 by 48 pixel sprites. So that's what I'm saying. If we really wanted to engineer this, you'd have all of these dimensions based on the size of the sprites. Ah, thank you, Brendan. Thank you very much. So in this case, if we've hit the enemy, we've got a successful collision. We want to reduce the enemy's health. Now we stored the enemy's health in this definition, so we'll have it, there we go, F health is going to be reduced by 1. I think we defaulted it to 3. We specify that in our spawn list. Yeah, there we go, 3 health. The bullet itself needs to be removed. Our enemy only removes itself automatically because we specified it to when it's off the screen or its health is less than or equal to 0. So we've updated the player bullets. Player can fire. No, we're not drawing player bullets yet, are we? So we'll also draw the player bullets. Very, very similar again. So you'll see we end up with just sort of all of these little one-liners scrolling through these lists. Player bullets will identify as cyan. Oh, got a bug. Error. Statement 1. Conversion from... Oh, dear me. I need to soften those up a bit. Oh, my bullets. They don't move. They stick statically. Why is that? I wonder if they collide with the enemy, though. Let's just see. Oh, all sorts of badness going on there. Let's have a review of what's happening there. Update player bullets. We're updating the speed. We specify the when we fire it. What? velocity are we giving it? Push to the back. Update bullets, update player bullets is the velocity plus the world speed. That seems fine. Just call them mines. Why are my bullets not moving? That's what I want to know. Oh, because I'm not updating the bullet. I'm updating the enemy bullets twice. Right. There we go. Knew I should have called them something else. There we go. Right. So right, what's happening is the fire key is not being very responsive, and that's because I'm only can fire under a certain set of conditions. So I just want to adjust those conditions slightly. This B can fire flag. Basically, we want to set that to false there, so it can't fire, and we'll make this instead a property of the engine. Can fire. This way, even if you've not fired, once that gun timer has been reset, you should get an immediate response to your mouse click. So just make sure that that works. Yeah, that's better. Keep the mouse held down or the spacebar held down, and we can start shooting. Now, I'm not making my player bullet disappear, so that's why they're basically killing the enemies in one hit. So I need to flag that when we actually hit an enemy. List player bullets, b.remove equals true. Oh, I'm not removing any player bullets, am I? No. Okay, so we'll just copy that. That was it's exactly the same lambda function as it was before, except the list is now for player bullets. Perfect. So the same rules apply if it goes off screen or it's been flagged for removal. So I should be able to hit this 1, 2, 3. Yeah, perfect. 1, 2. I can't remember what the conditions were for hitting. But anyway, we can now shoot at enemies. This one's a tough one. There we go. Now, I feel that the ship is moving a little sluggishly laterally, so I'm just going to tweak that value a bit. So when we're moving in the x-axis, I want to also perhaps double the speed at what we're moving at. And I also think it would be interesting to have it so that the player is also part of this auto-scrolling background. So you have to sort of continuously keep moving forward if that's what you want to do. So I'm going to do that by changing the player speed here relative to the world speed. Right now, player speed isn't in any way, the player isn't updated by the world speed at all. So if we're moving up the screen, I'm going to add the world speed to it. World speed. So that will sort of slow us down as we're moving forwards. And I want the opposite for the opposite direction, don't I? World speed. I think that's right. So what this should do is now make... Oh, it's not doing anything. It's just going the wrong way. Have I got those the wrong way round? Don't think so. Consult the prototype. My F world speed is... no, okay. What I'm not doing anywhere, rather oddly, and probably should have been one of the first things I do, is I'm not actually updating the player according to the background scrolling effect. Missed that one out. Never mind. It's not stopped us so far. So the player pos.y plus equals the scroll speed, or in this case the world speed, times f elapsed time. Right, so what this is going to do is also make now the player part of that scrolling universe. But this is also something we're going to have to think about what happens when the player ends up off the screen. You don't want the player to end up off the screen. So now I'm not pressing any keys. You can see the player remains relative to the world in the background. But I can fly forward let go of the thruster, and I start moving backwards relative to everything else in the game. So I think that adds a nice little bit of control dynamics to it. But we also don't want the player to be able to go off the screen. So let's clamp the player after we've done these movements. So if the player pos .x is less than or equal to 0, I'm just going to clamp it at that. X equals 0. And do the same for Y. So don't forget, we're looking at the top left of the sprite in this case. So now we want the other side of the screen. So if vPlayerPos.x plus float, what was it? It was 24, was it? Yes, 24. You know, I don't need the float. 24 is greater than or equal to screen. I will need a float cast here. Screen width. Then I want to clamp the player. PlayerPos.x equals float screen width minus 24. So that will stop the sprite going off the edges of the screen. Whatever we do for X, we'll also do for Y. It's not 24, I'm just thinking that whilst I'm typing it, it's 48 because the sprite is 48 by 48. 48 by 48. And that should be a Y. So we've got Y there, screen height, screen height. So that should now clamp the player to be, they can't leave the screen. Let's just double check that that works. So I'll try and push it off the bottom. Nope, can't do that. Bottom corner, can't come off the screen. Let's go and try the extremes. Right, I've got two things left to add, and then I think we're almost done. There was a few more things on my list, but I'm just a little bit conscious of time. So I'm going to add next, I think, I want to add some explosions. I mean, you've got to be able to know when you've actually had a successful thing. And explosions are going to consist of particles. It wouldn't be a live special if we didn't have an explosion in it. So I'm going to use my bullet class because that's already a particle. It's got a position and it's got a velocity. So I'm going to create another list. List fragments, which is going to be bits and pieces of ship that we blow up all over the place. And when I just need to update these lists just like I've done with all of the others. So if I've got any fragments in my list, the first thing I want to do is update the physics in exactly the same way as we did before. The nice thing is the fragments don't interact with anything, so we don't need to do any collisions with fragments. So let's put that in gubbins here. Update fragments. For auto f list fragments. And it's very similar to the updates that we've been doing. So I'm just going to cut and paste some code out of one of them. What have we got here? For bullets, it's just that. Except this time we've called it F. So just to cheat, I'm going to call that B. There we go. Stick a bracket in there. That would help. So all our fragments are going to do are behave like bullets. And they're going to exist until they go off the screen. So we want to also remove them in exactly the same way when they've gone off the screen. Remove if it says this time it's not player bullets, it's fragments. There we go. And we also want to draw all of our fragments. So again, quite a repetitive sort of sequence of events here. So we'll not draw them as circles because I think we're going to have a lot of fragments. I'm just going to draw them as individual pixels. So we'll draw them at that location. There is no radius, and we'll colour them in yellow so we can see that they're a bit different. So yet another list just of a standard type that we've been using throughout. But where do we create these fragments? Well, we create them when we destroy an enemy. And we can detect when we destroy an enemy because here is, there we go, when we're decreasing its health. We can check to see is its health equal to 0. Or less than or equal to 0. If that's the case, then we want the enemy to explode. And we want lots of particles. So in a very similar way to the fire pattern before, we just want to sort of randomly spam particles in all different directions. I'm going to have a lot of them. So let's start a little loop to create all of these particles. Let's have 500, I++. And I want them to sort of radiate outwards. So I'm going to choose a random angle and a random speed for each particle. And this is going to require a little bit of horrible C casting. So let's have F angle equals float rand divided by float rand max to give me a value between 0 and 1. And we're going around a full circle, so I can times that by pi. There we go, almost, by pi. And I also want something similar for the speed. So the bullets are going to travel at a high velocity, well the fragments are going to travel at a high velocity, but I don't want them to all appear sort of straight away. So I'm going to add a small offset to those, which I'm going to look at my prototype to tell me what was cosmetically very pleasing, was 50 in this case, there we go. That's our angle and our speed. And we're going to turn this angle and speed, basically it's a polar coordinate right now, we'll turn that into something a bit more Cartesian, is that the right one? By using sine and cos. And we'll just do this directly as we're adding it to the list of fragments. So I'll push to the back, a new fragment. The first set in our fragments, because it's a bullet, was the position. And the position is currently where the enemy is, plus the offset that we've become accustomed with now. So VF2D 24, 24. So that will start the explosion from the middle of the enemy sprite. Get these right. And then we want to set the velocity vector. It's putting in all these brackets everywhere for me. Don't do that. There we go. Our velocity vector is now the sine and cos using our angle and speed. So if we set that to, oh dear, I'll sort that out in a minute. Speed times cos of our angle. Yeah. Comma f speed times sine f of our angle. So we've set our position, which is the origin point of all of our fragments, and we've set dispersed around it with random speeds, random angles, our particles. Put you there. Is that about right? So we've caused an enemy to explode once we kill it. We draw our particles, yep, our fragments, and we're updating the fragments when they go off the screen. Are we updating the positions? Update fragments? Yes, we are. So we might be good to go there. Let's have a look. So I need to successfully kill something first. Boom! Like it. Do you know what? I want more. More particles. Let's put in 1,000 particles. Twice as many. Shoot the shit. Yes! That's what I want to see. Perfect. And we're maintaining a reasonably good frame rate too. I mean, that's not surprising. There's not a great deal going on. Right, I think we'll add one more thing, which is another type of firing pattern. Just to show, because we've not done one for a while, let's add another one in. firing pattern, and we'll call it Death Spiral. So I'm just going to take our circular pulse and it's going to behave in a similar way. What I want it to do is just constantly sort of fire lots of bullets sequentially like that. So I need to set a delay time. So I need probably most of this code anyway. Let's take that and that. There we go. So every half a second in this case it's going to fire something. But what I want it to fire is a bullet in an angle that's accumulating each time we fire. So I'm going to use a second slot in my sort of persistent memory for that enemy. And we'll increase the radius. Basically this is going to store the radial angle at which the bullet is going to fire. So we'll just increase that a little tiny bit each time. And then I want to add the bullet. So let's add the bullet. Take you and take you. So this time the bullet's position is the same as before, that's the same, but this time instead of it being f theta times I, it's going to be our parameter that we're accumulating. Not fire 1 in this case. And that's the same for both. Need to call it something else, don't I? Call that Death Spiral. And we'll add another enemy in. It comes at 500, a little bit later on. So 500. Its movement pattern. We'll go to the fast one. Was it move? What did we call them? Move fast. And we'll call this one Fire Death Spiral. And we'll give this the first enemy signature, and we'll start that off in the middle of the screen as well. I've forgotten a semicolon there, haven't I? There we go. So here's our 2 sinusoidal enemies coming in later on. Then we've got our 3. Death Spiral seems a bit feeble. That was rubbish. Right. Okay. Fine. Do it the other way then. Every 10 milliseconds it's going to fire a bullet. So circular pulses. Regular waves of enemies. Death Spiral, yes, there we go, that's better. Right, okay, do you know what? Everything should have a Death Spiral. Perfect. Yes. That's what we need. Right, good. And we can see that the performance isn't dropping out either. That's a nice thing. Right, just in case we're interested in performance, that was about 200 frames per second when it got nuts there in debug mode. So I'm going to just fire this up in release and just see what the difference is like. So currently trucking along at about 3,000 frames per second. Okay, 2,500, 2,200, 1,700, 1,500 frames per second. So we're not even sort of risking not having enough here. Now it's up to you how you creatively compose your scene of levels and movements and firing patterns and how to avoid things. And I think given that we've now been on for about 2.5 hours, I think, 2.25 hours, that's probably as far as I'm going to take it, because there's a few little announcements and things to mention at the end. So I hope that that's shown so how you can easily put together a shoot 'em up. I should just leave that running. Do you know what? Whilst before I end this, let's just duplicate some of these patterns a bit, just so it can keep going. Of course, you could be creative in how you create these patterns, right? You could, in principle, automate this somehow. You could have some sort of read it from a file, or you could algorithmically create them. Just stick a 2 in front of all. So I've got something on the screen. So yeah, that's a shoot 'em up that's incredibly flexible. So for every enemy we can create its own movement patterns. They could be much more sophisticated than what I'm showing here. They can create their own firing patterns. We could use the same firing patterns for pickups and bonuses and anything else. Very simple to change. We could add in more ship types, more sprites, and all sorts of things very, very easily now. We've got this robust framework. It doesn't leak memory. It operates at high speed. We can make it a lot of fun. It might need some sound effects, perhaps different types of explosions. There's all sorts that you can do, but as a base, this is not a bad place to start, because it's nuts, right? And then we like stupid stuff on this channel. So this has been the 100k special, and a couple of things I want to announce just at the end. Just make sure I've got a browser window with something open. Where has it gone? Right, if you didn't realise already on the screen, you will have seen that there is a prize draw available. There are 4 £25 Steam vouchers up for grabs. Just enter with a silly answer, and it's a prize draw, so the winners will be chosen at random. Just make sure I can contact you in order to send you the prize. That's my way of saying a big thank you to the community for helping me through this year. It's been a crazy year. Obviously, we've gained a lot of subscribers. The NES emulation series has been a lot of fun, took up most of the year. Next year, I'm planning on doing things a little bit differently. I'll just run that again. I'm not going to change the channel format too much. People like it, it's popular, but I might sort of look at the release schedule and the length of some of the videos. I'm anticipating in my professional life to be quite busy in the first half of next year, so I'm just making this statement right now. I might not get a video every 2 weeks for the first 6 months of the year. I'm going to try, and hopefully I'll be successful. I've got lots of ideas, but I might not be able to get it all out straight away. I've no plans on a big project for next year just yet. I know some people like to think in advance that I do. That's not happened, but I have got about 15 smaller algorithm videos that I want to film and show. So lots of content ready for next year. Other thing I wanted to announce is we have launched this community.onelearncoder.com blog. It's a bit sparse on content at the moment, but the idea is you guys, if you want to contribute articles, tech reviews, game reviews, talk about programming, development logs, whatever it is that you're interested in, it's just a place for us all to have a look at it, because nowadays some of my stuff gets a little bit of traffic. People may actually read it. It's these things get found in search engines now, and they get posted in our community. People will actually look at the stuff, so that should be a nice way. If you've got some good ideas or things you want to show, you can do it like that. So I think that leaves me to say, however you celebrate your festive season, I wish you all the best. Make sure you spend some time away from the computer. That's important too. I'm going to be taking a little break now until the end of January, February. I'll still be on the Discord, still may do a couple of live streams over Christmas, but in terms of videos, that is it from me for 2019. I want to send you a big thanks for 100,000 subscribers. Who knows what the next year will bring. I'm enjoying every minute of it, and I have no intention of stopping just yet. There will be a continued chat over on the Discord server. I'm not going to bed just yet, so if you want to come to the after party, please do. If you've coded along, show your stuff. Until then, I'll make sure the source code is up, enter the prize draw, and I'll see you all next time.